Alright, so it's May the 2nd. I did a little bit of work last night off camera. I just put in some brambles. I mean, these are the beginnings of brambles. I have a plant class, a bramble class, and they have some hitboxes, and I can interact with them. So it's extremely basic, but that's progress. But today I think I'm going to work on the console screen. So I guess I'm going to make a console class, and I don't know how I'm going to do the text rendering, but we'll see. Alright, so it's May 12th right now. It's been 10 days, and I've only done a little bit of work on the console class like I said I was going to. I do have some text rendering right now, and you can press the C. Oh shit! It's supposed to go back to a black background, but anyway, you're supposed to be able to toggle between the console screen and the main game screen. But something I did spend a couple days on is this thing is the first node in a node-based plant, because I'm moving all of my my node-based plant code over to SDL. I had made a... Actually, maybe I can show... yeah, I'm actually going to pull up what I made before, and then I'll show you. Okay, so I have this physics simulation here where there are these nodes that represent a plant, and you can see they kind of have some gravity going on and some like springiness between the nodes. It doesn't really look that realistic the way that these nodes settle down, and that's because well, just because the forces aren't really being handled properly. I'm only calculating torque forces, and I'm not calculating any translational force between the nodes. So I'm bringing this code over and sort of implementing it in Visual Studio here. I've got this node class here, this plant node class, and I've also made a vector class so that I can work with forces. I'll try and let you see the name of this song that's playing. I'm bringing this over, and I'm gonna actually handle the physics properly this time. I'll show you what I have in SDL so far. It's just the like duplication of the nodes. There's no physics going on. So I think the next thing that I'm going to do, I think I have a fairly decent idea of how to do the physics. It's not anything that I know for sure. I'm kind of figuring it out as I go, but I'm pretty sure I've got the physics mostly figured out. So the next thing I'm going to do is try and actually get these nodes to be able to move around. Of course, the reason that you need to have this physics is so that the plant doesn't grow like off, imagine the plant growing way out to the side like this. It would need to like fall to the ground or break or something. In real life, that's what would happen. So we need to have a physics world that's similar to physics on Earth, so that our plants can look similar to Earth plants. Of course, it's not actually necessary to have that similarity, but it would just look cooler if the plants looked sort of familiar. So yeah, that's why this physics is important. I'll also just mention that this little simulation, a pixelated version of it, is on my GitHub page. So you can just head over to this link. If it's still up on there when you see this, you can go and just click Add Cell and see how cool this is. I mean, this is going to be similar to the way that the plants are going to look in my game, but they're going to be much more complex than this, and they're actually going to be able to evolve. But it's kind of neat. I like it. I guess you probably don't care, but I'll link this in the description anyway if you want to check it out. Alright, so before I can get going on my physics, I really need to make sure that my vector class is implemented properly. And I pretty much just crunched out a bunch of these functions, and I don't really know if they're working properly, and it's kind of hard to debug. So I've written some extremely horrible code to draw some of these vectors as test vectors to the middle of the screen here, and I can actually, and so I can drag these vectors around, and I can test the various vector functions with these three vectors here. I'm getting some information about the vectors in the console, and so that's where I'm at. It looks like the well, one of the main vector functions is not working. This red one should be getting updated all the time when I change these two. But anyway, that's what's going on. So I'm probably going to just keep figuring out what is wrong with the vectors and fix that before I can actually get into the physics. Alright, so all of the functions of vectors that I think I'm going to need for the physics that I'm going to do are working. The most difficult ones were these: get component perpendicular to and parallel to. And I don't know if those are like, if these are done the way that people would normally do these. I don't even know if people would normally use functions like this, but when I was looking at the way that I'm going to try and compute the physics, it seemed to me like these functions would be useful to have. So I've got them set up here, and yeah, again, I'm not really very good with vector math or anything, so there might be a way to do this that's much simpler, but basically what they do is they split a vector into components based along the axis of another vector. So this is pretty small here, but you can see, I better turn this down. You can see that the blue vector is the vector sum of this red vector and this pink vector, and it's always split into these components along the axis of this light blue vector here. So I can change the light blue vector, and the components will change. I change this vector and the components will change. Always the components add to the dark blue vector along the axis of the light blue vector. And so yeah, I think this is going to be pretty useful. I'm going to use this to separate the force that is contributing to a torque force on an adjacent node, and the force that's contributing to a translational force, because the translational force can only be applied parallel to the connecting piece between two nodes, and the torque force is calculated with the component of the force that's in the direction perpendicular to the connection piece. So like if you imagine that this light blue vector, if there's a node at each end of it, and this dark blue vector is the force being applied to that node. So let's say this is the very top. So here, if I have a stack of nodes like this, and the very top one, let's imagine that this right here is the very top node, and then here's the second top node, and then there are going to be more attached beyond that. So we can see that this very top node in this orientation would be on this kind of an angle, on a pretty heavy angle. It's like, you know, mostly they're going to be pointing, they're going to be going more or less vertically. But anyway, the dark blue vector is the translational force, or the net force on the top node here. In this case, it would be only from gravity, is pointing directly downwards. There are going to be two kinds of forces applied to this node here. One kind is going to be bending the top node downwards, which is going to be the torque force, and that's going to be proportional to the component of the downward force, the blue vector, that is perpendicular to this, like, I don't know what this is called on physics terms, but like this arm here, this angle. And there's going to be another component of force that is parallel to this angle, which is going to actually push this blue node backwards like this. So just want to make sure I always show the song here. If you guys should check this out, just look up Code Radio if you're looking for some funky beats to listen to while coding, or if you just like any of these songs. But So like if you imagine a setup like this and you pull downwards on the top node like we're doing here, it's going to do two things. It's going to try and bend this node. I don't have good words to describe this, but it's going to try and I don't really have a good way of visualizing this for you other than by moving my mouse, but it's going to try and bend this top node down, which is going to kind of pinch this connection here, and it's also going to push along the axis of this it's like a stick. You can imagine like a stick between here and here. It's going to also push along this stick, and it's going to push this blue this node here out that way. And so it's not always going to be the case that the force on every node is going to be pointing directly downwards. Sometimes it's going to be pointing like that, sometimes it's going to be pointing like that. It depends, because the force kind of percolates down the entire tree, and is each force affects the forces below it. So we need to be able to easily calculate these forces. We need to be able to split them up into components that are going to do this pushing motion and this rotational motion, and we need to handle them separately. Or at least that's what I am expecting is that we're going to have to do. So these functions are working properly. And I also debugged a lot of my other vector functions. A big lesson I learned from this is like, I mean, I already knew this, but it's hard to do this in practice. It's like, it's really tempting to just like bang out a ton of functions and not really test them properly or not really debug them properly. But then when it comes time to like, you actually start using the functions and you realize that your output is not what it should be, and it's just really a nightmare to try and debug at that point, because you've got so many new functions that you haven't really thoroughly debugged that it's really difficult to track down where that problem is going to be, because there's so much new stuff. So really what I should have been doing is like, I should have started with these debug functions, which I'm using here to allow me to draw these vectors to the screen. I should have started with those and this print function, and just slowly one by one implemented all of the other functions. You can see there's quite a few here on vector, and I should have done these one by one and tested like all the weird cases one by one, and used the debug functions to check to make sure that they're right. And that would have probably saved me time in the end, and it would have, yeah, well, it just would have saved me time and headache. I mean, it wasn't that bad in this case, but yeah, so basically my takeaway from this is do small chunks of code, test them thoroughly before you move on to a new thing, even though it's really tempting to just like think that, or like hope that you got it right the first time and move on to something else. You probably didn't get it right. Like the chance that, I mean, especially with this kind of thing, because I'm not super familiar with vector math, and trigonometry always gives me a headache, so the chances that I got these functions right on the first try is pretty low. I'm getting better at it, but so I definitely should have done that a little differently, but I'm gonna learn from that. And yeah, also I probably maybe should have well, certainly could have downloaded a C++ vector class that was like way better than this and way more optimized and everything. It didn't seem like it was going to be that hard at the beginning, but this did take me like 3 or 4 days. I mean, I guess it didn't really take me that many hours overall, but probably should have just gotten one. But now that I've done this, I'm glad that I have, because I've, had to slog through this entire mess, and I can be a little bit more proud of it. But anyway, now we're pretty much ready to get on to implementing those physics, and so that's going to be really exciting. We still have not made any progress on the console screen or this movement, but I'm hoping that this is going to be like one of the slower features, the physics, because physics is like sort of notoriously difficult and math heavy. It's really math heavy compared to anything else that I can imagine that I'm going to have to be doing. I probably am going to have to come back to this class and add a few more things. I actually still have not even implemented these basic math functions. Although I think these are going to be really easy to implement compared to these. Probably could have done this in a smarter way. If you see any way smarter that I could have done it after looking at these functions, I would love to know. But yeah, I don't think anybody will, just because nobody cares enough to freaking slog through this, trying to understand this. Anyway, yeah, so I'm also thinking that I'm gonna restructure these videos so that each video corresponds to like a development goal, so like over a certain timeline. So I'll say like this video is gonna be from like the 15th to the 22nd, and I'm gonna try and implement this thing in that week, and then I'm just gonna record my progress throughout the week, and by the end of the week we're gonna see if I can pull it off or not. That's gonna help with like estimating timelines and sticking to goals, which I think is gonna make this go a little bit quicker, and estimating development timelines is a useful thing to start to get used to anyway. So yeah, I guess this will be the last part, the last segment in this video, and then I'll start a new one. Probably my next goal is going to be implementing the physics, actually. This video is mostly implementing vectors, but next video is probably going to be physics. So yeah, I think this is going to be maybe a little bit more interesting to watch as well, just because, you know, it's kind of a surprise. It's kind of a, like, you're not really sure if I'm going to make it or not. It's going to be, you're going to be on the edge of your seat the whole time. So I'm excited for that, and thanks for watching, and see you next time.